Didn't get my prompt in full. Need to change the code so that when the page loads, the neural net is trained once. Okay, we need to change the event listener. Initialize controller, training listener, setup charts. Await expression only allowed within async function. A train model is an asynchronous function, so you need to use await the keyword. Callback function add event listener needs to be an async function. Is it a good idea? Is it really a good idea to have a event listener as async function? No, it's not a good idea. So why are you suggesting it? Performing long-running tasks such as training a neural network, because it can block the main thread. Yeah, then you won't be able to press anything else, because at the moment, even if it's training, you can't see that one well. If you change the parameters, you can hit the train button again. There's no stop training. My CPU is going. I should use this one. That's the development. The other one is what we already have deployed. Should declare the event listener as an asynchronous. Trying to call a synchronous function train model inside the event listener. However, the event listener itself is not declared as an asynchronous function. Yeah. Yeah, this is what I don't like GitHub Copilot for. Let's go GPT quickly. The OpenAI one. Just have it on the side window here. Have it on the side window here. Thank you, Nitya to Nishu. Nice is nice. Okay, we really need to get this one going because we want to publish it. I mean, it's already there, you can try it out. Why is it training forever? Can try the current version. It's not great. We are updating it. There's an obvious thing of the color there. We did fix that the background will be white in the next version. And now we're trying to have it just a minor thing. It should be straightforward for, well, I thought Copilot to sort out, but it making a weird suggestion of making functions asynchronous, whereas I don't think they should be. So so might try GPT-4 quickly. Let's see if it picks up on any errors just with the code like that. Can also, if I'm losing the voice or feel like talking to someone. By the way, there is an option to go live. I can set up Zoom if you want to go live and have a chat. That is possible, but currently, as we just use the bot.
This JavaScript code snippet provides a robust setup for integrating charts into a web page using the Chart.js library. It's designed to visualize predictions and error trends related to a training model, likely a TensorFlow.js model based on the code structure. Let's discuss a few key points and possible enhancements. 1. Asynchronous initialization. The function train model is called in an async context in the DOM content loaded event listener, which is a good practice for initiating asynchronous operations once the document is fully loaded. However, the function call await train model is missing the async declaration in the parent function. You should define the callback function as async to properly handle this.
Okay,
JavaScript document.addEventListener DOM content loaded.
I do trust,
async equals
for some reason, I trust
initialize controls, add training listener, set up charts, await train model.
Of GPT-4 better than
2. Chart initialization and configuration. You've set up 2 charts using Chart.js for different purposes, one for predictions and another for error trends. This is implemented well, but ensure that the background color option you intended to set is correctly placed under the appropriate options properties. Currently, it's incorrectly nested under plugins, which might not apply the intended styles. Here's a correction. JavaScript options, plugins, tooltip, / tooltip options here. Scales, Y, begin at 0, true. Background color, white, correct placement if global setting is intended. 3. Model training and updates. The train model function handles model compilation and training, which integrates well with TensorFlow.js. The dynamic update of the charts based on training progress is a great feature, ensuring the UI is interactive and informative. 4. Chart updating logic. The functions update prediction chart and update error trend chart manage real-time updates to the charts during the training process. This setup keeps the user interface responsive and visually engaging. Ensure that these updates are efficient to prevent UI freezes during intensive computations. 5. Improving code organization. The code is mostly clean, but you could further modularize it by separating the concerns into different files or modules, e.g. separating chart handling, model management, and data handling into separate scripts. This enhances maintainability and scalability. 6. Error handling. Implementing additional error handling, especially around async operations and TensorFlow.js model interactions, would robustify your application. Consider try-catch blocks around network requests or heavy computational tasks. 7. TensorFlow.js usage. Make sure you have included TensorFlow.js library properly in your project, since this script relies heavily on its functionalities for machine learning operations. Overall, your script is well structured for its purpose, with just a few adjustments needed for optimal performance and error management. If you need further refinement or additional features, feel free to ask.
Yeah, feel free to ask. Okay, we do have, well, one thing we need to sort out the color correctly. Apparently GitHub Copilot made a mistake or something. Apparently, options, plugins. So here we have a tooltip. I don't know, do we need a tooltip? Probably not. I don't know what the tooltip is, but that's what goes into plugins instead of the background color. Oops. To format selection. Okay. Now we have the scales. Y scale begins 0, true. It's fine. And then we have the background color. Needed a comma there. Is that correct? Correct placement if global setting is intended. Okay. Let's see if it actually do have the tooltip. Don't think I need it, do I? Probably not. Yeah, we need to test it in production. These options should be the same. Here as well. Have white background. And let's deploy test in production. Also, eventually we'll have a link on the main page. What else do we need to do? Yeah, we have a bunch of tools coming out, this one as well. This one's also up and running. Again, if you're watching this stream, you have early access, so you can check it out before it's being formally released. How good is that? Okay, this one we need to redo. HTML. We don't really have an image for it. Okay, let's deploy first and go from there. Just deploy on another screen. This will ask for password. Everything we do is super secure, isn't it? No, not really. But if you do manage to break in, do let me know how you did it. Yeah, thanks. Thanks, Nitya, for hoping we'll get more subscribers. I'm not actually chasing subscribers, so that's okay. Okay, it's not working. Why? Could not no, that should be okay. It has some errors. Apache, yeah, we deploy using Apache. Not reliable tables. That should be fine. Syntax is okay. We did deploy. It just takes some time. And the site is running. Okay, we need to go Cloudflare and put this thing in development mode. Into development mode, because it seems like a problem with fetching caching on the DNS. Ah, come on. Yeah, this was GPT-4 made a mistake now. This probably was correct with what GitHub Copilot did. Not sure. Not sure. He turned the instead of the background. I showed the placement of the background color setting is correct because it seemed to not work properly. Yep.
In chart.js, the background color for the canvas where the chart is drawn isn't directly controlled by the options object in the chart configuration. Instead, the background color is typically set via CSS for the canvas element or its container. If the background color setting within the plugins options isn't working as you expected, it's likely because it doesn't directly influence the canvas background. Here are a few steps to ensure that the background color is applied properly. 1. Setting background color via CSS. The most straightforward way to set the background color is by using CSS. You can target the canvas element directly or its parent container. Here's an example of how you can do this. CSS prediction chart, error trend chart, background color white. This CSS rule sets the background color for the canvas elements with the IDs prediction chart and error trend chart to white. Ensuring chart background via chart.js configuration. If you want to use a chart.js configuration to set the background, this is typically done not at the chart's global options, but can be managed via plugin options if a specific plugin supports it. Chart.js itself doesn't have a built-in option for setting the canvas background color directly in the chart configuration. However, you can create a simple plugin to apply a background color. Here's how you can define and use a plugin in Chart.js. JavaScript chart.register ID background color plugin. Before draw, chart equals const ctx chart.ctx. CTX save, CTX.global composite operation destination over, CTX.fill style white. Set the background color CTX.fillRect 0, 0, chart.width, chart.height, CTX.restore. Then, when you initialize your charts, the plugin will automatically apply the background. This plugin will draw a white background before the chart elements are drawn, ensuring that the background is white. Hack 3. Check for conflicts. Ensure there are no conflicting CSS rules or canvas settings that might override your settings. Also, check that the canvas's transparency settings in the browser do not affect the visibility of the background. By using one of these methods, you should be able to control the background color of your charts effectively. If you still encounter issues, it might be helpful to check the specific version of Chart.js you are using, as some features and behaviors can vary between versions.
Okay, this is bad. Oh, why it's training for so long. And I need to reduce the batch size to begin with. Yeah, but it starts being jumpy like that. It's probably not a good sign. Then it doesn't really converge. Also not a good sign. It is converging. Slowly but surely. Yeah, the loss function got to a pretty low number. So that's a good sign. Doesn't look like it did very well at the end there. Can try a different activation function, maybe. Yeah, probably can restart. Yeah, you can on the fly while training, you can change parameters and hit the train neural net button again. See what difference it makes, if any. Yeah, we're really after the edge cases. So for example, you can add more noise. Where's noise level? 2 is maximum. Let's bring it back to tan H. Tan. I don't know how to pronounce it. Yes, we get now more noise in the signal, and we expect the neural net to struggle more. And yes, the loss function only gets to 0.4. You can see the conversion is not great. But this is deployed. This is in production. You have this description that you can read. It's really for placing ads there in between the text. Hopefully it won't need to prevent it from placing ads anywhere on the top of the page. But yeah, I'll deal with it later. I don't think anyone is particularly interested in that. Don't think anyone really likes ads. Do I have? Yeah. Do I have ads on this page? So I'm kind of happy with that. It's a training module, so don't expect too much out of it. We do, however, need a nice image. Wait, what happened to... Yeah, I thought we have an image for this. Yeah, normally when we publish, we have like a thumbnail of this. What else we got? So we got this tool still working, still testing. It's in production. Check it out. There's no links to it, so it's unlisted. So you only know about it if you're watching these streams. We also have that view. This from a Kaggle competition. A dataset from Harvard Medical School. It wasn't a great dataset, that's for sure. I didn't do much with it. It was just essentially looking at it. It's just loading the data. I have a lot of it. So it actually has a backend, so I need to make sure it's not too taxing on my server, because every time you select a different EEG ID, it's actually using an API to my server to retrieve the data. So that's another reason why I didn't really promote this tool. It's called Seizure Fuzz. I don't know if we are getting rid of it or not. Let me know what you think. I guess it will be useful for someone in the future who is looking at that a Kaggle, whichever way you pronounce it, competition data. The competition ended just recently, so you can actually go see what the solutions are, and we could potentially implement some of these solutions and actually deploy. It's all meant to be open source. It's an ensemble of 4 different models. This thief team member was doing something else. You can only guess what happened there. But they took first place. Now they won some prize money, which is great. And they did release the code. Yeah, I was talking to someone who had a lot of experience in image processing, but then not much with time series data. But this is a classic case where time series data is turned into an image. So this is EEG from whatever 20 channels, I think. Yeah, this many channels, standard 1020. Restart this quickly. Supposedly this is a seizure, even though you have that slowing down effect in the spectrogram. So but they're misaligned. The problem with this dataset is like the way it's being actually stored is not great, because the spectrograms are 10 minutes, the EEG snippets are whatever, 120 seconds, so on and so forth. So it's a bit of a mess in terms of finding anything in this dataset. A lot of patience. The labels were quite odd as well. I mean, yeah, the different types of spike discharges, different types of abnormal EEG activity that supposedly was labeled by experts, but it's just, yeah, I covered this before. There's just some weird things in the way the labels are.
This application is a web-based neural network training interface that allows users to train a neural network on the fly within their browser using TensorFlow.js. It's particularly useful for educational purposes, to visualize how different parameters affect the learning process, and for rapid prototyping of simple neural network models. Here's a breakdown of the different controls and how they could be used. Training set size. This slider adjusts the number of data points used to train the neural network. A larger dataset can potentially improve the model's accuracy but may take longer to train. Hidden layer size. These sliders control the number of neurons in the first and second hidden layers of the neural network. More neurons can capture more complex relationships in the data, but also increase the risk of overfitting and require more computational resources. Noise level. This slider adds a certain level of randomness to the training data, simulating real-world data imperfections. It helps to test the robustness of the neural network against noisy data. Learning rate. This is a critical hyperparameter that affects how quickly the model learns. Too high a learning rate can cause the model to converge too quickly to a suboptimal solution, while too low a rate can slow down the training process significantly. Epochs. This slider sets the number of times the learning algorithm will work through the entire training dataset. More epochs can lead to a more trained network, but also increase the risk of overfitting if too many are used. Batch size. This determines the number of samples that will be propagated through the network before updating the model parameters. Smaller batch sizes generally require less memory and can update the model more frequently. Activation function. This dropdown lets the user choose the activation function for the hidden layers. Options like ReLU, sigmoid, and fan dictate how the neurons in the network will transform the input signal into an output signal. Optimizer. This dropdown allows the selection of the optimization algorithm that will minimize the loss function. Choices like ADAM, SGD, and ADAGRAD offer different approaches to the learning process. Loss function. Through this dropdown, the user can choose the loss function the model will use to compute the quantity that a model should seek to minimize during training. Options include mean squared error, mean absolute error, and mean squared logarithmic error. Train NN button. When clicked, this button starts the training process with the selected parameters. It's the action trigger for the model to start learning from the data. The two charts display in real time the performance of the neural network. Prediction chart shows the actual data points versus the predictions made by the neural network. Training loss chart illustrates the model's loss over each epoch, providing insight into how well the training process is going. Overall, the application can serve as a didactic tool for understanding neural networks and a practical instrument for researchers and hobbyists interested in experimenting with machine learning without needing to set up a full-fledged environment. Understanding fluctuations in neural network loss during training. If you're observing fluctuations or jumps in the loss, especially if the loss increases sharply at certain points, this could be due to several factors. Learning rate. If the learning rate is too high, the model may overshoot the minimum of the loss function. The learning rate of 0.04 could be too high, causing instability in the training process. Batch size. A batch size that's not appropriate for the dataset might cause erratic updates to the weights, leading to fluctuations in the loss. Optimizer. Although ADAM is robust, it might still require tuning of its parameters, like learning rate schedules or beta values, to stabilize the loss. Data quality. Make sure the data is clean and pre-processed correctly. Anomalies or outliers can cause sudden changes in loss. Model complexity. Ensure that the model is appropriate for the task. Both underfitting and overfitting can cause erratic loss patterns during training. Randomness. Stochastic processes in training can cause variability. This includes the random initialization of weights, random shuffling of the dataset, and randomness in dropout layers, if used. Loss calculation. Ensure the loss is averaged correctly over batches and epochs. Summing losses without averaging can cause misleading spikes. To reduce the fluctuation, try a smaller learning rate or use learning rate schedules to decrease it over time. Consider tuning the batch size, starting with smaller batches and increasing if needed. Introduce techniques like gradient clipping to limit the effect of very large gradients. Implement early stopping to hold training when the validation loss starts to rise, which can prevent overfitting and reduce the likelihood of these spikes. Use a more complex model evaluation approach. Instead of just looking at loss, also look at validation metrics. Loss might not tell the full story, especially if the distribution of errors is skewed. Remember that manually fine-tuning hyperparameters can be quite tedious. You might want to implement a more systematic approach, like a grid search, random search, or even more advanced methods like Bayesian optimization, to find the optimal set of hyperparameters. When training neural networks, especially when using stochastic algorithms like SGD, stochastic gradient descent, or its variants, like ADAM, is expected to get different results across runs even with the same initial parameters. This is due to the inherent randomness in the training process, including but not limited to random initialization. Neural networks typically start with randomly initialized weights. Even slight differences in these starting values can lead to different training paths and results. Data shuffling. If the training data is shuffled before each epoch, which is common practice, the order of data seen by the network changes, which can affect the updates to the model. Stochastic gradient descent. The optimizer itself is stochastic. Adam, for instance, calculates adaptive learning rates for different parameters from estimates of first and second moments of the gradients. The stochasticity in the gradients will lead to different updates. Hardware. The computation may involve floating point arithmetic, where operations can be non-associative due to rounding errors, leading to small variances. Parallelism and concurrency. The way computations are parallelized on the CPU, GPU can also introduce non-determinism. Improving neural network performance for sinusoidal function prediction for a neural network model tasked with learning a sinusoidal function without noise. Achieving a near-perfect prediction is feasible, especially if the network architecture, learning rate, and other hyperparameters are suitably chosen. Here are some suggestions to fine-tune your existing setup to improve model performance. Simplify the model. Since the task is to predict a sinusoid, a simple model should suffice. You might not need 2 hidden layers. Try with 1 hidden layer first, and only add a second one if necessary. Hidden layer neurons. You may not need as many neurons. Try starting with a smaller number and increase only if the model performance is not satisfactory. Learning rate. The learning rate may be too high, leading to overshooting the minimum loss. You should consider lowering it or using a learning rate schedule to decrease it as training progresses. Activation function. The choice of ReLU, rectified linear unit, is fine for hidden layers in many cases, but since the sinusoidal function involves both positive and negative values, _than might be a more suitable choice as it outputs values in the range, -1, 1. Loss function, mean squared error, MSE, is appropriate for regression problems, and since you're predicting a continuous value, it's a suitable choice. Epochs and batch size. Your choice of 200 epochs and a batch size of 10 seems reasonable, but these may need to be adjusted based on the model's learning curve. Optimizer. Adam is generally a good optimizer, but if you find the loss fluctuating too much, you might want to try SGD with momentum or experiment with different hyperparameters for Adam. Randomness. TensorFlow, JS, like many deep learning libraries, includes randomness in weight initialization and data shuffling. While you can't set a global seed, try to ensure consistency in other ways such as data preprocessing and model initialization. Regularization. If you have a larger model or add noise later, you may need regularization techniques like dropout or L1 per liter 2 regularization to prevent overfitting. Data normalization. Make sure the input data is normalized or standardized if you start working with more complex or varied datasets. Evaluate on unseen data. Ensure that you're evaluating model performance on a separate test set that the model hasn't seen during training to get a true measure of its predictive power. Experiment systematically. Change one hyperparameter at a time to see its effect on the model's performance. This can help you understand which parameters are most sensitive and need careful tuning. Based on these suggestions, you can adjust your training script to conduct more systematic experiments and converge on an optimal set of parameters that yields the best performance for your sinusoidal prediction task.
Yeah, obviously this is a much simpler model. Doesn't require that much detail. So these parameters that are set by default seem to work okay-ish. Okay, to 0.12. If we reduce noise, should in theory go lower. Yeah, when it's jumpy like that, it's not a good sign, but might still converge. Still 0.14 or so. It's gonna go any lower? Yeah, probably not. Adding more data points. Seeing at 0.1 something at the moment. It can get all the way down to 0.01. Yes, now it's 0.06. So I have the training set size is 100, doesn't make much difference. Number of hidden layers 5. A second hidden layer size is 3. Noise level 0. Now learning rate. Just try edge cases. So it's obviously too small. Still manages to converge 0.05. Yeah, I'm not sure how learning rate affects the result. It doesn't seem to make much difference in this case. We do need some nice thumbnails for we'll do those, and so we can post the results. It will be good to have example images there as well, potentially. That would be more useful while we edit. Some sort of like comparison of two actually pop it into so yeah, the aspect ratio of it might be not great. Do default values as well. This one has some noise in it. Could be nice to have the final result. Yeah, if we're sending data to the server, because currently the Flask application doesn't have a backend. Well, it does have a backend, but it doesn't do anything. We could use the backend to send to store results. That might be too complicated, maybe. Yeah, we like different examples. Let's pop the noise level all the way to 2. See what happens. We expect the loss function to be much higher and not much convergence happening. That's right. Let's do an example like that. So this one converged, the first one converged much quicker. This one has a lot of noise in it. We already had the default value, didn't we? This one for some reason is different. Yeah, there's that non-deterministic aspect of it. Even between runs with the same settings, you get different results. Get different results. So we already have something similar to a learning rate of 0. A bunch of examples there. Yeah, Adam doesn't do well. No, it does. It takes longer. Yeah, might be enough. The rest you can try the tool yourself. I don't want to give you all the results, do I? Just pop them in there. Yeah, pop them in there somewhere. Don't remember which one's default. Don't remember which one's default. We also need the call it new neural net example 1. Let's turn it into JPEG. Yeah, they're relatively small files. That's good. Why do I have so many? I don't know. Five of them. And we also need to choose one for a thumbnail for this application. What? I never quite understand. I'm pretty sure it will work in production. It doesn't work on the testing server. Have to be in there. Sure, if I just call the HTML, it will. No. Let's GitHub cop out quickly. Yeah, with the context of the whole project. You always get stuck on this little fix. Anyway, we'll fix it later. In the meantime, go check out bionicchaos.com. And yes, you'll be seeing some advertisement, but you will be supporting the project this way. And don't forget to provide your feedback. See you next time. Bye. Can do some music at the end if it works. Might be loud, so beware.